Good evening. This is the notes for Pre-AP Pre-Cal for Monday, September 11th. I hope you enjoy your 2 days at home. I hope you have a smile on your face as you're watching this video. I know that I do as I'm recording this video. Remember, we are lifelong learners, and we use every second of the day to prepare you for your future endeavors in math. So it's not going to be bad. Just please watch this. Please complete your assignments. I'm still planning for a major assessment on Friday, your major assessment on Friday. So please, please watch these videos, stop, pause them, replay them as much as you want. I will answer questions Wednesday, but everything that I ask you to do is due on Wednesday, please. So first thing I'm going to do is we're going to start with our math workshop. I have posted this as an assignment on Google Classroom. So look for this on the wall. But right now I'm going to do these with you. We're going to do 1 through 4 and numbers 18 through 19. Now I'm going to do them on a piece of notebook paper so you can see them better. So number 1, and you can do it on notebook paper as well since you do not have a hard copy of the math workshop. Number 1 is the tangent of 4 pi. Tangent of 4 pi. Well, that is going around the unit circle 2 times. So that's one of those major points. That is 1, 0. Because if you have 4 pi, go around it 1 times 2 pi. Go around again, it's 4 pi. So that's a major point. You want tangent. Tangent defined as y over x. So I have 0 divided by 1, which is 0. My answer is 0. Number 2, the tangent of 7 pi over 6. I want to change this to a mixed number to help me find the location of this. This would be 1 and 1/6. So if I went here 1 time, I need 1/6 more. So would it be in quadrant 3 or quadrant 4? I hope you said quadrant 3. It is in quadrant 3. The reference angle is pi over 6. Remember, we have this big test coming up September 19th, not this Tuesday, but next Tuesday. The ordered pair that associated with pi over 6 is square root of 3 over 2 and 1/2. It's in quadrant 3, so they're both negative. They're both negative. Tangent, like we said, is y divided by x. So I have negative 1/2 divided by negative square root of 3 over 2. Negative 1/2, change the division, multiplication, and flip. Okay? These 2's cancel out, and negative times a negative is a positive. Got 1 over square root of 3. Okay, I cannot submit an answer like that, so I need to rationalize. I need to rationalize. So I'm going to multiply the numerator and the denominator by square root of 3. And I get square root of 3 over 3, and it is positive because a negative divided by negative is a positive. Number 3, cosecant of 390 degrees. I want it to be an angle from 0 to 360. So think about it for a moment, what I would do to find an angle, to get an angle from between 0 to 360. Okay, I hope you said subtract it from 360. Yes, I subtract that from 360 and I get 30 degrees. So I'm really working with 30 degrees. That is in quadrant 1. That is, of course, the reference angle. That is square root of 3 over 2 and 1/2. Cosecant is the reciprocal of sine. So sine is your y value. The reciprocal of that is 2. My answer is 2. Number 4, tangent of 60. 60 is, of course, in quadrant 1, so it is the reference angle. The ordered pair associated with 60 degrees is 1/2, square root of 3 over 2. Tangent is y divided by x. I say this divided by that, square root of 3, 2, divided by 1/2. Leave the first one alone. Change the division, multiplication, and flip. So I get square root of 3. Square root of 3 is my answer. All right, let's look at the bottom ones. That was our trig review. We're going to do some equation review. Let's look at number 13. 5a squared minus 4a minus 1 equals 0. 5a squared minus 4a minus 1 equals 0. Okay, it is a quadratic equation. It's set equal to 0. That's good. It is in the form of variable squared, variable, no variable. So it's either easy or bust them up. I hope you're thinking bust them up, because it is bust them up because the coefficient's greater than 1. So I got to multiply these last two. It's got to multiply to give me negative 5, add to give me negative 4. And the two numbers to do that is negative 5 and 1. Negative 5 and 1. So I'm going to bust this middle term up. 5a squared minus 5a plus 1a minus 1. I could take a 5 and an a out of that. That leaves an a minus 1. I could take a positive 1 out. That leaves an a minus 1. So I've got 5a plus 1 and a minus 1. I'm going to set both of them equal to 0. When you do that, you get negative 1/5 and 1. Negative 1/5 and 1. Take a moment to look at that. Alright, let's look at number 14. We have the square root of 2k minus 3 equals k minus 3. Okay, this is a radical equation. In a radical equation, you want to isolate the radical. Well, I have it already isolated here, so there's not much more I can do than just square both sides. When I square this, the radical goes away. Here I would have to come over here and FOIL k minus 3 times k minus 3. When you FOIL that, which I'm not going to do, you should know how to FOIL by now, is k squared minus 6k plus 9. Well, this has went from a radical equation to a quadratic. So I need to get it set equal to 0, move both of these over. Factor is easy, and when you factor that down, you get k equals 6 and k equals 2. Remember, when you get more than one answer for a radical equation, you have to plug it back into the original to see if both answers work. If I plug 6 in, 2 times 6 is 12. 12 minus 3 is 9. Square root of 9 is 3. Okay? 6 minus 3 is 3. 3 equals 3. That is an answer. Plug 2 in. 2 times 2 is 4. 4 minus 3 is 1. Square root of 1 is 1. 2 minus 3 is negative 1. 1 does not equal negative 1, so 6 is my only answer. Two x squared equals negative 2x. Move this over. Because it's quadratic, I get it set equal to 0. GCF, take a 2x out, that leaves a x plus 1. All you can do is GCF. Since this does have a variable with it, you got to set equal to 0. That gives me 0, because I divided by 2. And then x plus 1 equals 0, x equals negative 1. You do not have to check your answer on that, but on radicals you have to. Take a moment to look at that. Alright, the next thing we're going to do is review our learning targets that we've learned so far, because we do have a major assessment coming up on Friday, September the 15th. Alright, first learning target that's on to be on this test is I can determine the a Rocco function. That's the average rate of change. And let's just look at this number 2 right here. We're not going to work it all out. We're just going to practice setting it up. You have this function, f of x equals x to the 4th plus 2x squared minus 5. Okay? X to the 4th plus 2x squared minus 5. And you want to know what's going on from the interval -4 to -2. -4 to -2. Alright? Give you a second to think what type of function this is, the specific name. I hope you're thinking quartet, which belongs to the polynomial family. So we want to set this up. Like I said, I'm not going to work it all out. I'm just practicing setting it up. Remember, x sub 2 goes there. X sub 1 goes there. Right above be f of -2, and right above this be f of -4. And of course, this is a double negative. You would make this positive. But then you would have to plug -2 back into this and -4 back into this to get the values that go for there. I already have this one worked out. You would plug f of -2 into this. Remember, when you plug -2 into the calculator to the 4th power, you must put negative bases in parentheses or it will not give you the correct value of 16. It will give you -16, which is not correct. So I got 19 here. I put 19 there for f of -2 minus f of -4 is 283 and come out to the answer of -132. We've done a lot of those. I feel confident that you would do well on those. Okay, the next learning target that's on the test is I can identify parent functions and graph transformations. I'm not going over the parent functions. You should be able to identify and graph them based on the equation. But I do want to go over this transformation problem. G of x equals -2 times x plus 1 squared plus 3. The parent function is quadratic. If I had to describe this, first, work from the inside out, move left 1 unit, stretch, since the 2 is on the outside, is stretch by a factor of 2. There's a negative, reflect about, when it's on the outside, what is it? It is x-axis. And then finally, move up 3 units. That's the correct way to give the description. Left 1 unit, stretch by a factor of 2, reflect about x-axis, move up 3 units. Yes, I'm aware that since there is a number here, you would make a table for this particular function, and when you multiply by -2, it would take care of the stretching and reflecting. So you don't have to do something in particular for the reflecting because it takes care of it, but you do have to tell, if you gave a description, you had to tell me both of those. Alright, so let's graph this. Alright, graph the mother first, the parent. Make a table. Alright, first thing, this means really move left 1, so I'm going to add -1 to each of these. This is stretching by a factor of 2 vertically. That means I'm going to multiply my y. But I'm also going to take care of the reflection by going ahead and multiplying by -2. And finally, simply move up 3. Moving up 3 affects the y, not the x. That's why the x stay the same. That's going to be negative 5, 1, 3, 1, and negative 5. Now I'm going to graph this. 1, 2, 3. And my answer does make sense. It reflected. It moved to the left some and up 3. So that is my reflection for this is my transformation for this parent function, the quadratic function. Take a moment to look at that. Now, in your Google Classroom, I have posted, I was planning on giving this project out to tomorrow. Now, this is not due to September 28. Let me repeat. September 28. Not this week, not next week, but the next. September 28. I will give you a hard copy of this one as you return Wednesday, but if you want to go ahead and read it over, there's your transformation project. Like I said, it's posted in Google Classroom. Look on the class wall. Next, I want to review graph and piecewise functions. We did these last week. I'm just going to do a couple of these to refresh your memory. We have one here that involves 2 pieces. This first one is the parent quadratic function, so you just need to graph the parent quadratic function first. Okay. The next one is y equals 2x plus 1. It is linear, therefore you can use slope and y-intercept. So I'm going to use my y-intercept is 1, go up 2 over 1. Up 2 over 1. Up 2 over 1. Okay, now let's look at our number that's important. Something's going on at 1. I'm going to come over here to 1. Now, it's saying on this first piece, the quadratic, for all x values less than or equal to 1. So, if I go right here, and I go up to where it's at right here, that's where, from this point, is where it hits this function. It wants for all x values less than or equal to 1. That is this way. That would be a closed dot, this part, this way. And I would erase this part over here. Now, I will go back to 1, go up to where I hit the other function. That is an open dot. And it says for all x values greater than 1, which will be this way, this way, this way. Okay? Let's look at our domain. Starting from left, that arrow keeps going, that arrow keeps going. It would eventually hit all numbers. If I stop here, guys, you don't have to stop here, because even though it's open, that's closed, it cancels each other out. So it's all real numbers, the domain. Range, start from the bottom. 0. Even though there's nothing over here, it hits something over here. We're good. Even though it's open here, it's closed over here, so it's good. So it's 0 to infinity. we're going to look at one more piecewise. This one has 3 pieces, involves 3 pieces. Okay, so let's look at our 3 lines for graphing. We got y equals 8. So that is a horizontal line. See, if you have y equals some number, that's a horizontal line. You go to y equals 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and draw a horizontal line. Y equals 2x. Y equals 2x. Go to 0. Y-intercept is 0. Slope is 2. 1, 2 over 1. 1, 1, 2 over 1. 1, 2 over 1. 1, 2 over 1. Backwards. And then you have y equals negative 4 minus x. Negative 4 is y-intercept. 1, 2, 3, 4. Down 1 over 1. 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 And backwards. Okay, on this first one, it's at negative 1. So I go to negative 1. I go up from negative 1 where I hit this first graph, the y equals 8, because I graphed it first. And it wants it for all x values less than or equal to negative 1. Well, that would be this way. The x value is less than or equal to that one. So it would be a closed dot, drawing a line this way. Now, go to the 2x, which is this one. Go to negative 1 down till you hit it, which is here. That would be an open dot. And then you go to 4. 1, 2, 3, 4. And that would be an open dot. Now you got to determine, now it wants it from the x value from negative 1 to 4. So it wants from here to here. Well, these values are from here to here, so I would erase this and this part. I just want the x value from the area that covers from the x values of negative 1 to 4. Then I come from 4 and I go down to right here. Closed dot. It wants the area that spans x is greater than or equal to 4. That means all the x are, so this spans that region right there. So that would be my piecewise for this 3-piece function, this piecewise that contains 3 parts. Now the domain and range, this one's a little tricky. Let's look at domain. If I start from here, this arrow means it keeps going. Even though this is open, it cancels out. There's still something hitting the x-axis. That's open. That's closed down here. It cancels. And that keeps going. So domain is easy. That's all real numbers. But the range gets a little tricky here. If you start from here, this arrow keeps going. I know it's from negative infinity. But when you get from, guys, it hits it to here, but there is nothing in between here to here. it's like the function's here and it picks up back here. You've got to break in the range. So this is at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Let's make sure of that. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Bracket, because it's closed. Union, pick back up at -2, and there's a parentheses because it's open, and it keeps hitting the Y, keeps hitting the Y. Okay, here it goes up to 1, 2, 3, 4, 5, 6, 7, 8. Goes up to 8. Even though it's closed here, even though it's open here, it's closed here, it would be a bracket because that cancels out. So your range would be from -infinity to -8, bracket, union, -2 to 8, bracket, because there's a break in between here. There's nothing in between there of the function. Okay? Next, I want you to get out your homework from Friday. It looked like this, and we're going to go over this. Our learning target from Friday was I can determine the composition of functions graphically. And remember, when I talk about composition of functions, I'm talking about using the structure of one function to help evaluate the structure of another. Composition, the makeup, the structure. Okay? Now, up here, we're going to look at these tables first. I said we didn't use tables on Friday, but they are very similar to graphs. I want you to try these, okay? On this first one here, remember, let's look at 37. We have two tables. This is the G table. This is the F table. So make sure you see that. G table, F table. We work from inside out. We got 2 is next to G. So I go to the G table. Find what 2 is equal. 2 is equal to 3. I put 3 there. Now I want to find F of 3. Go to the F table. 3's here. Your answer is 9. This is G of 1. Go to the G table. Find the value of 1, which is 9. Now I'm going to do F of 9. F of 9 would be equal to 6. That is my final answer. G of 9. G table. G of 9 is equal to 12. Now I'm going to find F of 12. Go to F table. 12, that is 5. G of 5 is 6. F of 6 is 7. Work from inside out. F of 6, go to F of 6, which is 7. Now find G of 7. G of 7 is 4. G of 7 is 4. Now F of 4 is -3. F of 12. F of 12 is 5. I put 5 there to help remember what I got to find. Now G of 5. G of 5 is 6. F of 3. F of 3 is 9. G of 9 is 12. Using one function to help find the other function, evaluate the other function. Now let's look at graphically. This is the F function. This is G function. Make sure you look at your diagrams before you start. G of 1. G is over here. G of 1 is 2. Now F of 2 is 0. Let's go back through that. G of 1 is 2. F of 2 is 0. G of -3. -1, -2, -3. That is -2. F of -2 is 1. F of 1 is negative 2. G of negative 2 is negative 1. F of negative 1 is 2. G of 2 is 2. Now, it can be F of F, so you just do it twice. F of 3, 1, 2, 3 is negative 1. Now do F of negative 1. F of negative 1 is 2. Okay? G of 0 is 1. G of 1 is 2. Remember that it can be written like this, like you see right there, F of G, or it can be written, all that means the same. You just start from the one it's next to, get that answer, and get that answer and plug in the furthest away. Work from inside out. I will do this first, and then get that answer, and then do the F of that. Work from inside out. That means the same thing. Okay, I want to turn back to page 63 in your notebook. Page 63 in the notebook. This is from the notes on Friday. And we didn't finish answering 13 and 14. I want to talk about that. Number 13 says, is it possible for f of g of x to equal negative 1? Explain. Okay, I want you to think about this for a minute. And when you're thinking about this, I want you to go up here and look at this and this. Okay? Take a moment to think about that. Okay? Let's talk about this. In the end, I hope you said no on this. Yes, you start with g of x and you work backwards. In the end, you're doing f of something that you get. If you look up here, it says the f function is only defined from 0 to 5. So therefore, that is no. It can never equal negative 1. So that is no. Because f of x is only defined for x from 0 to 5. Okay? Now, today's learning target is I can determine the composition of functions. I can determine the composition of functions. Alright, I want you to turn to page 65 in your notebook. That's where I'm coming off of, page 65. Write your learning target in your notebook. Learning target. I can determine the composition of functions. And right here, I want you to practice again. What does it mean? What does it mean? It can be like this. X is closest to G. You plug in G first and then F. It can be written like that, or it can be written like that. Either way, that means the same thing. Okay? We're not doing all of these. We're only going to do certain ones that's highlighted. So I'm going to do the first two. And it says, let f of x equals 3x, g of x equals x plus 7, and h of x equals x squared. I know you have trouble seeing it up here because this is blurry, but you do have it in front of you, okay? So I'm going to write these down here on notebook paper so you can see it. F of x equals 3x. G of x equals x plus 7. H of x equals x squared. And yes, we did do something like this. We did do this in Algebra 2 with trig last year. So this first one we're doing, this first box has F of G of 5. And that's how you say it. F of G of 5. Practice that with me now. F of G of 5. Okay, the 5 is closest to the G. So that means I'm going to plug the 5 into the G function first. G of 5 equals x plus 7. The way I'm writing it is the way I expect it to be written on your paper. Whatever's in this parentheses is what I plug in for this variable. That equals 5 plus 7. That equals 12. That is not my answer. This does help me get my final answer, but that's not my answer. G of 5, I plug that in the G function at 12. Now I take that, and that's f of 12 equals, my f function is 3x. 3 times 12 is 36. So that is my final answer. That is what that is equal to. F of G of 5 is equal to 36. Work from inside out. Take this, plug in the G function, get that answer, plug it into the F function. Okay, I'm going to do the next one. G of h of negative 2. Okay. My f function is 3x. G function, I'm just going to write these so you can see them where I'm getting this from. That's in your directions here. Okay. So the negative 2 is next to h. So I will evaluate that first. H of negative 2 equals, h function is x squared. Remember, when you put that in the calculator, you put negative bases in parentheses before you do the exponents. That's going to be a positive 4. You should be able to do that in your head by now. Now, this is not my answer. I take this and I plug it into the G function. G of 4 equals the G function, which is x plus 7. Whatever is in this parentheses goes in for that variable. And 11 is my final answer. 4 plus 7 is 11. So this whole thing is equal to 11. So you go back up here and put 11. Now, what if, I'm going to go and do this one. What if you have 3 of them? You just work from the inside out. Do this first, then plug in the G, then plug in the H. So we have H times G of F of negative 4. So F of negative 4 equals the F of X, which is 3X. 3 times negative 4 is negative 12. Now I'm going to plug this value into the G function. G of negative 12 equals x plus 7. Whatever's in parentheses goes in for that variable. Negative 12 plus 7 equals negative 5. Now I take the negative 5, plug in for h. H of negative 5 equals x squared. Negative 5 squared is 25. That is my final answer. So this whole thing is equal to 25. So this is what I can determine composition of functions. You taking the one function, using it to evaluate another one. It all deals with structure. Let's look at the next part. it says, let f of x equal 4x, g of x equals 2x minus 1, and h of x equal x squared minus 1. And we're just going to do these two because these are very similar to the ones we just did. H of g of 4. Make sure you know how to correctly read that. H of g of 4. 4 is next to g, so I'm going to plug that in first. G of 4 equals 2x minus 1. And I get 7. Now I'm going to do h of 7. And I get 48 as my answer. So this entire thing is equal to 48. Now this one is f of negative 3. You would take the negative 3, plug it into f, get the answer, and plug it back into f again. So, f of negative 3. Negative 3 is closest to f, so I'm going to do f of negative 3. The f function is 4x. Get that to be negative 12. Now do f of negative 12. F function is 4x again. 4 times negative 12 would give me a negative 48 value. So that entire thing would be negative 48. All right. Now, for the following next few problems, these last 4, it says for each pair of functions, find f of g of x and g of f of x. State the domain. Now let's notice something different from these down here up here. They had numbers up here. Down here they have just the variable x. Just the variable x. Okay? So I'm going to copy this problem on a piece of notebook paper so you can see it better. And at the top of this paper I'm going to put we're finding f of g of x and g of f of x. Okay? On this first one, number 3, f of x equals 2x plus 5 and g of x equals 3 plus x. These are not hard. You just got to take your time and listen to what I'm going to say to you. We're going to find that this first one, f of g of x. Okay? Just like we did the number, the x is closest to g. So I'm going to plug x into g first. G of x equals, the g function is 3 plus x. You say, okay, Mr. Harris, hold on now. There's not a number. If I take whatever's in parentheses and plug it in for the variable, it stays the same. Yes, in this case it is. Remember, whatever is in that parentheses is what you plug in for that variable. X is closest to g. I put g of x. My g function 3 plus x. If I plug x in for x, it doesn't change it. That's all I can do with that. Now I'm going to move to my L function. So L of 3 plus x equals my L function is 2x plus 5. Whatever's in this parentheses is what I'm going to plug in for that variable. Equals 2 times 3 plus x plus 5. I substituted this in for my variable. Distribute. Combine like terms. I get 11 plus 2x. That is my answer for this entire f of g of x. Let's go back to what I did first. I wanted to find f of g of x. X is closest to g. I do that first. G of x, my g function, 3 plus x. I take x, I plug in x, it doesn't change anything. It stays the same. Now, f of this, I plug this into the L function and get the answer 11 plus 2x. Now, you notice something here. It says state the domains once you do this. Okay, that reviews what we learned in past weeks. The only time we had to worry about domains if it was either rational or radical. This one answer is neither one, so your domain for this will be all real numbers. Now, let's do g of f of x. G of f of x. X is closest to f, so I do f of x. My f function's 2x plus 5. I take x, I plug it in for x, it does not change it. So that's all I can do for there. Now I got to take this and plug it in for g. G of 2x plus 5 equals my g function is 3 plus x. 3 plus, I substituted this value in for x. I put it in parentheses just to let you know that I replace x with that. Also, I do this in case this was minus. I know this plus has no effect on it. It doesn't change sign. But what if this had been a minus right here? The minus would change all the signs. That just reminds you. So I'm going to rewrite that without the parentheses. Combine like terms. I get 8 plus 2x. You could have 2x plus 8. It does not matter. So the entire answer is 8 plus 2x. This is neither a rational nor a radical, so your domain is all real numbers. So that means you can plug any number in the universe and get that. Okay? We're going to look at number 4. F of x equals negative 2x squared minus 5x plus 1, and g of x equals negative 5x plus 6. And once again, I want to find f of g of x and g of f of x. Okay? I'm going to find this first one right here. F of g of x. X is closest to g. G of x equals the g function, negative 5x plus 6. I take x, I plug it in, it does not change it. Now I'm going to move to the f. F of negative 5x plus 6 equals negative 2x squared minus 5x plus 1. Wherever there's an x, I'm substituting this value in for it. So negative 2 times negative 5x plus 6 squared minus 5 times negative 5x plus 6 plus 1. Now this gets a long problem here. Remember, I got to square this. I can't just simply square this and this. I got to do the FOIL method. So I'm going to come up here and do the FOIL method. Gives me 25x squared minus 30x plus 36. 25x squared minus 60x plus 36 is my value once I FOIL that out. So now I'm going to substitute that in for that. Negative 2 times 25x squared minus 60x plus 36. Now, I'm going to come back and distribute. That gives me negative 50x squared plus 120x minus 72. Negative 5 times negative 5 is positive 25x. Negative 5 times 6 is negative 30 plus 1. Combine like terms. Negative 50 x squared. 120 and 25 gives me positive 125x. Negative 72 and negative 30 gives me a negative 102 plus 1 being negative 101. Okay, that would be what my f of g of x would be equal to. So that would be my answer for that problem. We want to state the domain for that function. We want to state the domain. It is not radical, it's not rational, so my domain is all real numbers. Now I want to find g of f of x. X is closest to f. Do that first. F of x equals negative 2x squared minus 5x plus 1. I take x, I plug it in for x. Does not change it. Now I'm going to move to g. G of this answer, which is that answer right there, my g function is negative 5x plus 6. Wherever there's a variable, I'm going to plug this in. Whatever's in parentheses, I'm plugging for that variable. So equals negative 5 times negative 2x squared minus 5x plus 1 plus 6. Negative 5 times negative 2 is positive 10x squared plus 25x minus 5 plus 6. Combine like terms, and that is my answer. 10x squared plus 25x plus 1. Domain, all real numbers. We're going to do one more, and that's going to be it. Just one more. We're going to do number 6. We're going to hold the other ones for the next taping. Okay. Number 6. F of x equals x squared minus 9. G of x equals square root of x plus 3. We want to find f of g. Oh, on number 6, hey, it worked out even better. We're only finding f of g of x. We're not under these same directions anymore. We're just finding f of g of x, and it does not say anything about domains. We're just finding f of g of x. Okay. X is closest to g, so I do g of x equals. This is number 6. We're going to come back to number 5 in just a minute. We're doing number 6. G of x equals square root of x plus 3. I take x, I plug in for x, it does not change it. Now, take f of your answer. The f function is x squared minus 9. The square root and the square does what, class? It cancels out. So you're left with x plus 3 minus 9, which is x minus 6. So that is equal to x minus 6 is your answer. You plugged x in for x, did not change it. Got this? Plugged into F function. F function is this. Took what's in parentheses, plugged in for my variable. It canceled the square root and square out and combined like terms. Okay, let's look at number 5. We want to find f of g of x. Our f function is 2 over x minus 3, and our g function is x squared plus 6. Okay, x is closest to g. G of x equals x squared plus 6. I take x, I plug it in for x, it does not change it. Now I take f of this. My f function is this. Take this, plug it in for x. Put it in parentheses because it's replacing the x. Rewrite it without the parentheses, and that gives me 2 over x squared plus 3. That is my answer. Take a moment to look at that. Okay, your homework assignment for this lesson. This is due Wednesday. You need to do it now. It's page 59 in your workbook, page 59 in your notebook, page 59 in notebook, numbers 1 through 4 and 8. 1, 4, and 8. That's graphing piecewise. And page 69 in your notebook, numbers 1 through 15 odd. Numbers 1 through 15 odd. That reviews what we just did, composition of functions. Like I said, this is due Wednesday. This assignment and what you're going to have for Tuesday. All right, well, I'm about to upload this. Have a great day off tomorrow, but make sure you watch the video. Thank you. And learn. Please stop and learn from the video. See you.